All right, so next up in chapter 9, we've got parabolas, and we've seen parabolas before. We've graphed them. We're going to be introducing a little bit of new vocabulary today, so that's what is new about this section. So parabola, I'm not really going to write down a definition. I just want to draw a little sketch here. So let's draw, we've got y-axis, x-axis, and just sketch in a parabola, right around there, something like that. Okay, so that's our parabola. So what I'm going to label on here are a whole bunch of important points. So you know this one right here, that's the vertex. And then you know the axis of symmetry. We've seen both of these things before, so those two are not new. Here are the two new things. So, I'm sorry, a couple of other new things. So there's a point right here that we call the focus, and I'm going to label that and make it a different color. So we've got, the vertex, which you know, the axis of symmetry, which you know. So this new point right here is the focus, and the importance of the focus is it's basically, that's the definition of a parabola, is based on its distance from the focus. And so the definition of a parabola is points on a curve that are equidistant from a point that we call a focus and a line that we call a directrix. So I want you to label in a horizontal line right here, and that horizontal line we call the directrix. Okay, so any point that you find on that parabola is going to be equidistant from this horizontal line and that point. So say you pick like this point right here. The distance down to the directrix is exactly the same as the distance over here to the focus. That is the definition of a parabola. The farther you get from the focus, the farther you get away from the directrix vertically. So the last thing that is new here is this line right here. It's always a horizontal line, and it goes from endpoint to endpoint here on the parabola, and it goes straight through the focus. And this line right here, this is called the lattice rectum. Yes, the word rectum is in there. Let's all get over it right now. So that is a horizontal line that goes right through the focus, and so the length of this line right here basically will give you an idea of exactly how wide the parabola is going to be. Okay, so some of these things you've seen before, like I said, some of them are new. So we're going to write a little info here on the two different types of parabolas that you'll see. So this is the type of parabola that you've worked with before. They either open up or down. And this, when we have x equals, it actually flips it on its side. So we could have a parabola that looks like this or a parabola that looks like this. So it's basically turning this thing on its side. So let's write a whole bunch of info here. So here is our vertex form. That's basically the standard form that we're going to be working with today. So the direction of opening, it opens up if A is a positive value right here, otherwise it gets flipped upside down. We remember that from the first time we saw parabolas. If A is negative, that means our parabola gets flipped upside down. Okay, and the vertex, when we're in this form, is just h comma k. Now be careful here because there's a minus h there, so it actually ends up being the opposite of what you see right here. And the axis of symmetry is a vertical line going right through the x value of the vertex. So that stuff's old, this stuff's new. The focus is given by this. So it's got the same x value as the vertex does. Notice that, they're right on top of each other. And then the value is k plus 1 over 4a. So it's basically like at the vertex, but just a little bit higher. So that's what that 1 over 4a does. Or if a is negative and your graph is upside down, then it would just be a little bit lower. And the directrix is the exact opposite. It's just a little bit lower than where the vertex is. So the directrix is a horizontal line, which means it's a y equals line. And it has the same value, k, as the vertex does, but then it goes down just a little bit. And it goes down the same value that the focus goes up. And then that way, they're the same distance from the vertex. Okay, and the length of this line right here, the lattice rectum, it is 1 over a units long. Okay, and we actually are going to put that in absolute value just in case the a is negative. Okay, so that is our new info. We're not going to focus too much on this stuff right now. It's going to come back into play later once we start writing equations. And now this column is entirely new. This is if we have x equals. So these parabolas are actually sideways rather than up or down. So they look like either like that or like that, whereas these ones look like this or like this. Okay, so it opens to the right if A is positive. So it'd be like that one right here, opens to the right, or it opens to the left if A is negative. The vertex is actually still exactly the same. It is still HK. You get the value of x from right here, and then you get the value of k as the opposite in parentheses there. The axis of symmetry is actually going to be a horizontal line now, because if your parabola goes like this, the axis of symmetry would be horizontal, and it goes right through the vertex. That would be y equals k. It's got this same value here. And the focus starts right here. It's either going to move left or right. So what that means is that the value of y is actually still the same, and it's the value of x that just moves a little bit. So it's going to move just a little bit away from this value of h, but the value of k will be the same. And then for the directrix, if our parabola is turned on its side, the directrix would actually be a vertical line this time, like this. So it's going to be an x equals line. And it starts at this value of the vertex, but instead of going up just a little bit, it goes down just a little bit. Okay, and the length of the lattice rectum is actually exactly the same. So remember this from before, A gives us either a stretch or a compression, so this basically tells us exactly how wide or how narrow that stretch or compression will be. If A is like a big number, then 1 over A will be very small, and so this will be very narrow. If A is a very small number, then 1 over A will be large, and this will be nice and wide. So that kind of explains why a fraction of A made our parabola wider, and a whole number for A made our parabola narrower. Okay, so we're going to use this to do some graphing, look at standard form, things like that. Okay, so standard form, like I said, is actually the vertex form, which is the same form that we had on the previous page. And then when we talk about general form, that's the one that you've seen before, the ax squared plus bx plus c. Okay, so we've also called this vertex form before. So the first example, we are going to write this parabola that's written in general form. We're going to write it in standard form, and that requires completing the square, if you guys remember that from earlier in the year. So when we complete the square on this parabola right here, y equals, one of our first rules of completing the square is that we're not allowed to have a value right there in front of the x squared. So what I'm going to do is I'm going to factor it out. So if I factor a 4 from the 4x squared, I'm just left with an x squared. And then if I factor a 4 from the 16x, I'm just left with a 4x. And the way completing the square works is I'm going to have a constant right in there. I just don't know what it is yet. And so kind of ignore my 34 for now. Just kind of push it off to the side. I'm going to worry about the completing the square step for right now. Okay, so inside the parabola, kind of pretend nothing else exists. Hopefully this is familiar to you, the completing the square step. We start with this middle number right here, the 4, and we cut it in half and then square it. Okay, so again, we take this middle number, cut it in half, and then square it. So when we take 4, cut it in half, we get 2. Square it, we get 4. So that is the number that we say completes the square. Hopefully that is familiar to you from earlier in the year. So now if you look, we just took our equation and we just threw in a number that wasn't there before. So now be very, very careful. What we technically just tossed into that equation was 4 times 4, which is 16. So there's now a 16 in my equation that wasn't there before. So what I do to balance out adding 16 is I subtract 16. So now my equation is no different than it was when I started. It's just going to look different. It's going to be in a different form. So now let's write it in that form, 4. And then this, when I factor it down, what multiplies to 4 and adds to 4? That would be 2 and 2. So that's going to be an x plus 2, x plus 2. Or I can write it as x plus 2 squared. And then 34 minus 16, that would be 18. So this is now in this standard form right here. You can see all the pieces, the A, the H, the K. So let's identify all of these things here. So the vertex, you take the opposite of this value, so negative 2, and then this value, 18. For the axis of symmetry, the axis of symmetry is a vertical line that just goes straight through this point right here. It has the same x value as my vertex was, so it's just x equals 2. And like I said, that's a vertical line. And then the direction of opening. Since this is a y equals, it either opens up or it opens down. And since a is positive, it opens up. Okay, so that's all that they asked me for with that one. So I got it into my standard form, and then I was able to quickly identify all of this info here. All right, so now we're going to do some parabolas, graphing parabolas, I'm sorry. In chapter 4, like I said earlier in the year, we learned how to graph this. This is like the standard, easiest parabola that you could possibly graph, this one right here. It goes right through the origin. So let's do just the tiniest graph of this. This goes right through the origin, and it's kind of like that's our standard for stretching. It's not stretched, it's not compressed. This is like the original parabola. Okay, so this y equals x squared is this graph right here. So this, there are 3 different transformations. It is translated h units. It's like whatever this value of h is, that's a horizontal translation, either left or right. K units, whatever that is, so maybe 3 units or -2 units or something vertically, that goes up or down. And then according to A, it is dilated, which means either stretched or compressed, or it could be reflected by A. So remember, if A is negative, you'd see a reflection, and if A is something other than 1, you'd see a dilation, meaning either a stretch or a compression. Okay, so we're going to look at these 2 really quickly, and we're going to talk about how they get moved left, right, stretched, reflected, anything like that. So if you look at this original compared to this one, the only difference here is the 2 out front. So that 2 tells me that I am going to be stretched by 2. Okay, and that's the only difference. So I want to show you something here. I want to look at the original. So in a different color here, I'm going to graph the original just so you can see for comparison. So that is the original. And so what I'm going to do now is graph this equation. Okay, so this that I just graphed here is this one, the original. When I stretch, it's like I'm taking these and like pulling them upwards, so it'll get narrower. So it'll look something like this. It'll still go right through the origin because I didn't move it left or right, but it'll be narrower. So a stretch by 2 means it's stretching this way. All right, so that's that first one. Now this one, we also have that stretch by 2. We've got the number out front. So it's going to be exactly as narrow as this one was, except this. So the -1 means it moves 1 unit to the right. Remember, when I'm inside those parentheses like that, it actually does the opposite of what I think it's going to do. So a -1 means 1 unit to the right. And then the -4, when I'm outside the parentheses, it does exactly what I think it's going to do. So 4 units, the negative actually does go down. Okay, so let's graph this one. So I'm going to do the exact same thing. I want to show you what my original looks like. So this is just for comparison, so you can see the transformations that have been made. So that's my original x squared. I'm going to take that graph, I'm going to move it 1 unit to the right. I'm going to move it 4 units down. So when I say it, what I'm talking about, what I'm moving, I'm talking about the vertex. The vertex here is sitting right on the origin. I move it 1 unit right, 4 units down. So here's my new vertex. And then remember, it's stretched by 2, so it's going to be just as narrow as this one is. Okay, so it's going to look something like this. Okay, so that is my new parabola that I have for this equation right here. All right, let's look at a couple more. So now we are going to graph these ones right here. Now these ones are in like a very strange form. This first one is anyway. So now keep this in mind. If I have x equals, I'm going to have a horizontal axis of symmetry. It's going to be totally flipped on its side from what I was used to on the first page. So this, what I want to do is get an x by itself. Okay, so if I, let's see, subtract 3x, and I have -y squared equals x plus 25. So that x is almost by itself. I need to subtract 25 from both sides too. Okay, so I have -y squared minus 25 equals x, or since we're used to seeing it in the opposite order, x equals negative y squared minus 25. Okay, so if we compare it to this thing right here, there's a negative out front, and the negative tells me it gets flipped. But instead of flipping upside down, it actually flips to the left. And if you look at the stuff that we have written right here, it flips to the left if a is less than 0. Okay, so it's going to look like this. And then there's nothing inside parentheses here, so that means the y value doesn't change. But what this does is it moves it down 25 units. Okay, I'm sorry, not down, it's actually going to move it to the left. So my vertex, my y value doesn't change, so my y value is still 0. But this number on the outside, remember this number on the outside is actually the h. And my vertex goes h and then k. So that is my vertex, and I know it flips to the left. These ones are a little weird to wrap your head around just because it's a brand new type of graph. So we'll kind of check in when I see you guys to make sure you're okay with this type. Okay, so we have to go 25 units to the left, so let's scale a little. Let's make this negative 5, negative 10, negative 15, negative 20, negative 25. And then the y value is 0, so it's sitting right here. All right, so the original sideways parabola looks something like this. Okay, it goes right through the origin and it opens up to the right. So that's the original. What this one did here is it moved it 25 units over here and it flipped it over to the left. So it's not stretched or compressed or anything. So it should have the same width as this one does right here. So your parabola is going to look like that. Okay? Next one, this is back to y equals. So this is either going to be up or down, not left or right. And this one we're going to do the same thing that we did on the front. We're going to complete the square to get it into standard form, also known as vertex form. So y equals, there's no number in front of this x squared. So I just get to kind of block off the x squared plus 6x. And then remember, we're going to pick some other number right here that's going to complete the square. So kind of push your negative 4 off to the side for right now. So that's where we're at so far. We didn't have to factor anything down. So if you look inside the parentheses, remember like I explained to you in the front, we take this middle number and we cut it in half and then we square it. So if I start with 6, when I cut it in half, I get 3. When I square 3, I get 9. So I'm going to add the 9 right here. But remember, just like what happened on the front, I just added something that wasn't there before. So in order to balance it out, make sure I still have the same equation. If I add something that I didn't have before, I have to balance it out by subtracting. That way, plus 9 minus 9 is 0. It's not actually any different from my original equation. It's just going to look different. So y equals, this right here factors to x plus 3, x plus 3. So I write it as x plus 3 squared. Remember from chapter 4, this number right here is half of this number right here. Makes it really easy to factor that down. And then combine up my outside, I get negative 13. Okay, so I am going to plot a couple things. So my vertex is, remember, the opposite of what I see in parentheses for x, and then exactly what I see on the outside for y. And there's technically just a 1 out front here. So it's not stretched, it's not flipped. All I'm doing is moving my vertex. So let's start just as a sketch with the original parabola, just for comparison. Okay, and I'm going to move 3 units to the left. Let's scale this whole thing by 2. Okay, so scale this by 2 as well. 4, 6, 8, 10, 12, 14. There we go. So I'm going to move 3 units to the left, so right here in between negative 2 and negative 4, and then 13 units down, so my new vertex will be right there. And then I just sketch this one. So no stretch, no compression from the original. So it should be pretty much this same parabola right here, just shifted down here. Okay, so that is our graphing section. The very last thing we're going to do is we're going to be writing equations for the parabolas. So we're going to be flipping back and looking at this stuff a lot because it's going to give you one of these 5 things and ask you to kind of piece everything together so you can put it in this form. So the first thing we're going to have to determine is whether it's this form or this form. So let's flip back here. So the vertex is 1, 3, and the focus is 1, 5. So if you look back here, notice that the vertex and the focus have the same x value. So here, the vertex and the focus have the same x value. Here they don't. So that's how you know it's supposed to be this form. So let's start with that. So the vertex is HK. Okay, so I know that. I'm going to write down what form I know it's supposed to be in so we can find all the missing pieces. Okay, so we're trying to find A and H and K. So I know HK is 1 and 3, so this one's actually pretty easy. It pretty much handed me the H and the K. And then the focus, I'm going to take this formula right here. So I know that H and then K plus 1 over 4A is equal to 1, 5. Okay, so again, I know exactly what H is and exactly what K is. So let's start writing this equation. So I don't know A, so I'm going to leave a blank spot right there. I have X minus, and H is 1, squared, plus, now my value of K is 3. So the last thing I have to figure out is what A is, and I can do that from this right here. Okay, so I know that K is 3. So 3 plus 1 over 4A. So this must be 3 plus 2. So I know that 1 over 4A must be equal to 2. That's how I'm going to figure out what A is. So let me run you through that again. So I know K is 3, and 5 is 2 more than 3. So when I added 1 over 4A to K, 1 over 4A must be the same as 2. So these come out equal. So I'm just going to do some quick algebra here. I'm going to multiply both sides by 4A. Okay, so these will cancel. And then I have 1 equals 8 times A. It's 2 times 4A. And divide both sides by 8, and that's how I get A by itself. So A is 1 over 8, so just plug that right in here, and that is my equation. Okay, and then graph the equation. So let's just give it a quick sketch. Okay, so my vertex is 1, 3, positive 1, 3. So right there, and then the 1/8 means it's pretty wide. All right, so this tells us that the length of the lattice rectum is going to be 8 units wide. So it's actually going to be pretty wide, maybe like that. Okay, so far wider than the original. Okay, next one. We've got the focus and we've got the directrix. So if we look, our directrix is an x equals. So look here. Here the directrix is a y equals. Here the directrix is an x equals. So it must be this form right here. Okay, so x equals a times y minus k squared plus h. Okay, so we're just going to kind of fill in the blanks, get everything that we have here. So the focus is 5, 6, so let's flip back. Here's our focus formula, h plus 1 over 4a, and then k. We know that's equal to 5, 6. All right, so our k value is basically given right to us. There's no formula that we have to solve for there. So we know what k is. And then the directrix is this formula right here, h minus 1 over 4a. We know that comes out to be -2. Okay, so here's what I've got so far. I basically have like a little system of equations. H minus 1 over 4a, I know that's equal to -2. Then if I look at this right here, I know h plus 1 over 4a must be equal to 5. So I'm going to write that right underneath. Okay, so it's just like a system of equations. Whoops, that's a plus. I'm just copying it from right here. System of equations, do you remember the addition, or also known as the elimination method, where you'd line up the variables right on top of each other? Can you see right here, these two variables are exactly the same but opposite, so they cancel each other out. And then I just add the two together. So I have h plus h, which gives me 2h, equals, and then I add -2 and +5, and I get 3. Okay, so to solve for h, I'm going to divide both sides by 2. And 3 over 2 is 1.5. So that's my value of h. So now I have my value of k, which they basically handed to me. And then I have my value of h. So I'm going to plug h into one of these equations, and then I'm going to solve for a. Okay, so I'll plug it in right here. So 1.5 plus 1 over 4a is equal to 5. I'm going to subtract 1.5 from both sides. So I get 1 over 4a is equal to 3.5. Then to get the a, I'm going to multiply both sides by 4a, just like I did up above, so this cancels. I get 1 equals, you can multiply 3.5 times 4, you'll end up with 14a, and then finally to get a by itself, we divide both sides by 14. Okay, so that's my value of a is 1 over 14. So let's plug that all in right here. So 1 over 14, y minus the value of k was 6 squared plus 1.5. All right, so that's my equation. Again, we're going to give it a quick sketch. So for my vertex, the y value is the opposite of what I see here, so I'm going to go up to 6. And then the x value is exactly what I see here, so I'm going to go over to 1.5. So my vertex is right there. This tells me, since it's positive, that it opens to the right, and it's going to be nice and wide because of that 1/14. So something like that. Okay, we are going to cut it here. I think we will do that last example, example 5 in class. We're getting a little long here.